Okay, excuse me. In the last video, right toward the end of the video, my battery went dead on my phone, so I'm not sure exactly what you heard and what part you didn't hear, so I may be a little redundant on this video, saying some of the same things again over that I did on the previous video, but either way, it'll be good for you to hear. So we were looking at solving quadratic equations, and we have looked at 3 of the 4 methods. The 4th method was called, is the quadratic formula. And I told you that the good thing about the quadratic formula is it solves all quadratic equations. Now there's 2 things you have to remember about using the quadratic formula. Number 1, to use the quadratic formula, you must put the equation in the quadratic equation in standard form. Now, what do I mean by standard form? That means that you have to make the problem look like this. And you've written this down several times. This ax squared plus bx plus c equals 0. This is when the quadratic equation is in standard form. That means it has to be set equal to 0. And this has to be in the right order. And then I also gave you the quadratic formula. The quadratic formula in the last video, I do believe you got the quadratic formula down, was this right here. So you need to remember to put the problem in standard form, and you need to memorize the quadratic formula. Now, if you'll notice in this quadratic formula, you see 3 different letters: A's, B's, and C. Now, but if you look up here in the standard form, you also see A, B's, and C. This A, B, and C, these A's, B's, and C's down here correspond to these. Now, what does that mean? It means that when you put a quadratic equation in standard form, whatever is in front of the x squared, we call that A. The number that's in front of x squared is your A. If there's no number in front of the x squared, it's understood 1. You say, Mr. Randall, what do we do if we don't have an x squared at all? That's not possible. Remember, every quadratic equation, the distinguishing feature about every quadratic equation is, first of all, it has an x squared term in it, and not only that, it'll have an equal sign. So you will always have an x squared term. So A will never be 0. Now, if you don't have an x term, that means B is 0. If you don't have a constant term, that means C is 0. So B or C could be 0 in these problems, but A can never be 0. Okay, let me just show you this. You don't have to write this down. I just want to show you something, then we'll do some examples together. So look at these problems right here. So if I was going to solve this problem right here by the quadratic formula, the first thing you have to do is make sure that it's in the right order. It is. And you have to make sure that it's set to 0. It is. So then A would be whatever's in front of x squared. So A would be 1. B is whatever's in front of x, which is 3. And C is the number that's on the end. Now, notice when you get C here, C is -7. Not 7. Now, if I hadn't had this middle term, that meant B would have been 0 then. Or if I didn't have the -7, then that would have meant C would be 0. So you don't have to have an A, B, and a C. Now you have to have an A, but B or C can be 0. All right, this problem right here, is this a quadratic equation? Yes, it is. But be careful. Don't get your A, B, and C from this line. Put the equation in standard form first. So to put this in standard form, it has to be set to 0. So I'm going to move this term over to that side. And then when I do, or subtract 8 from both sides is technically what you're doing. Then this is your A, which is 5. B, now understood, -1. C, -8. Same thing here. This is a quadratic equation. But if I'm going to solve it by using the formula, you have to put it in standard form first. So you'd have to subtract the 3x across, subtract the 1 across, and put it in this order. Then A would be 7, B would be negative 3, and C would be negative 1. And then you take these three numbers, stick it straight into that formula, and solve the problem. Okay, so what I'm going to do with you here is I'm going to do as I typically do. I'm about to put up a problem, and I want you to pause the video and copy the whole problem. Then after you copy the whole problem, I will go back and go through it line by line and show you where everything comes from. So, write these instructions down, and we're going to do 3 examples here. The instructions to these next 3 problems solved by the quadratic formula. Excuse me. Solved by the quadratic formula. Just a second, let me make sure you can get everything on the page. I think that's everything. Let me look right here. Yes. Okay, pause the video now. Pause the video now and copy this. Okay, I'm assuming that you've just copied it, so let's go back all the way up to the start now. And go through this problem. So this is what the original problem right there would look like, solved by the quadratic formula. Now, if you'll remember, I said the quadratic formula solves all quadratic equations. So here's what I want to do right quick. It turns out this one could be solved by the factoring method because this factors. So I want to show you what the 2 answers to this problem would be since I can factor this. All right, you don't have to write this down. To solve it by the factoring method, step 1, it's got to be set to 0. It is. Step 2, factor this. Well, how does x squared plus 5x plus 4 factor? There's no GCF. This is a trinomial, the easy case. The x squared breaks up as x and x. This tells me the signs are the same, both plus. So it's x plus, x plus. Then I need 2 numbers. If you multiply them, you get 4. But if you add them, you get 5. Multiply 4, add 5. That's 4 and 1. So this factors as x plus 4, x plus 1. Now set both of these equal to 0. X plus 4 equals 0. X plus 1 equals 0 to get my 2 solutions. X equal negative 4, x equal negative 1. So remember that. Again, you don't have to write this down, but remember the 2 answers are negative 4 and negative 1. Now, let's solve this same problem by the quadratic formula. If the quadratic formula solves all of them, it should certainly solve this one. So let's do that. Okay, so how do we use the quadratic formula? First, you have to put it in standard form. It is. Next, get A, B, and C. A is whatever's in front of x squared. B is whatever's in front of x, and C is your constant term. So there's your A, B, and C. Now what I want to do is I want to take those 3 numbers and plug straight into the formula. I would suggest that you write the formula down every single time before you use it. The reason is the more times you write the formula down, the easier it is to memorize. Also notice on this formula, the division bar is not just under this part. It comes all the way back to right here. So this is above the division bar as well. Now what I'm about to do is I'm going to take 5, put it right here. 5, put it right here. 1, we'll put it right there. 4, I'm going to put it right there. And then 1, I'm going to put it right there. So every place you have an A, put a 1. Every place you have a B, put a 5. Every place you have a C, put a 4. So that's what I did in the next line. So I've got negative, B is 5, plus or minus the square root, B, which is 5 squared, minus 4. The 4 is always there because it's part of the formula. A is 1, C is 4, all divided by 2 times a, put another 1 there. All right, you don't have to put these in parentheses. I find it helpful particularly when a, b, or c are negative. When one or more of those is negative, it's easier to keep straight if you put those in parentheses. So I would suggest using the parentheses. All right, orders of operations. We're going to do what's under the radical first. Exponents first. 5 times 5 squared, which is 5 times 5, which is 25. Everything else, bring the negative down, bring the 5 down, plus or minus, square root of 5 squared is 25, minus. Now, multiply straight across. 4 times 1 is 4. 4 times 4 is 16. All divided by 2 times 1, which is 2. All right, 20. Now do what's under the radical. So I squared and then I multiplied this out. Now, 25 minus 16 is 9. So that's negative 5 plus or minus the square root of 9. Now, the square root of 9 is 3. That's negative 5 plus 3, plus or minus 3 over 2. Now, I mentioned this to you earlier, but in one of the previous videos when we were using the square root property. But let me say it again here. If this had an I with it, you can't add this. You can't add this with this if it has an I with it. Or if it has a radical left. But since the square root of 9 is 3, can you add negative 5 and 3 together? Yes, you can. Can you subtract negative 5 and 3 together? Yes, you can. So for that reason, I broke this up into 2 answers. The first answer is negative 5 plus 3 all over 2, and negative 5 minus 3 all over 2. So this is the first answer, this is the second answer. Now, what is negative 5 plus 3? It's negative 2 over 2. And negative 3 minus negative 5 minus 3 is negative 8 over 2. And that reduces to negative 1 and negative 4. And by the way, if you will look back up here, that is the exact 2 answers that we got. Now you say, well, my goodness, Mr. Rainer, it's a whole lot quicker to do the factoring method. That's why anytime I have an option, if I can use the factoring method or the square root property on it, I had much rather use it than, the quadratic formula. Quadratic formula still works, still give you the same answer. It's just a lot more work involved. I mean, look at the work that we just did. Look at this problem right here. So factoring is certainly easier if it is factorable. Having said all of that, when it comes test time, I will probably tell you on test which technique I want you to use. The main reason for that is twofold. Number one, because I want to make sure that I ask all of the methods. And then number two, to make sure you know them. So I will tell you which methods to use more than likely on which problem. But after this test or after this chapter, you use whatever method you like, once we get through this section. Okay. Now, if you've been watching your videos, and I have hammered you to death about that, but if you've been watching your videos, you should have this example right here where we worked it before. If you go back to completing the square, we completed the square on this problem, and we got an answer. If you'll go back to completing the square, it was the second example that we worked together. So when I use the quadratic formula, I should get the same answer on this one. All right, so let's do that. Let's just see if we get the same answer. All right, I'm going to uncover this, let you copy it. Okay, so pause the video now and copy this example. Okay, now let me quickly go through this one with you. So first, is the problem in standard form? Yes, it is. Next, get A, B, and C. A is whatever's in front of x squared, which is understood 1. B is whatever's in front of x, which is 10. C, which is the constant on the end, which is -7. As I suggested, I'm going to write the formula down first. Now, I'm going to put it in parentheses. So bring the negative down. Wherever I have a B, I'm going to put a 10. Plus or minus the square root of B, which is another 10, squared, minus 4, that 4 is always there, times A, which is 1, times C, which is -7, all over 2 times A, which is also 1. All right? Now, work what's under the radical. Don't touch anything else. -10 plus or minus the square root of 10 squared is 10 times 10, which is 100. So that's where this comes from. Now be careful right here. Multiply straight across. 4 times 1 is 4. 4 times 7 is 28. But this negative times that negative makes that go positive. That negative and that negative made that go positive right there. Now, 100 plus 28 is 128. Now take the square root of 128. Bring down the -10, plus or minus. Now, where does the 8 square root of 2 come from? Square root of 128 is divisible by a perfect square, that being 64. So rewrite 128 is 64 times 2. Break this into 2 square roots, and the square root of 64 is 8, square root of 2. So that right here is where that comes from. Square root of 128 is 8 square root of 2. Or, remember I told you that you could use your calculator to work that as well. Now the last thing, I told you this in completing the square. I told you that if this number, if there's something that goes into all 3 of these, you can reduce it. Well, is there something that goes into 10, 8, and 2? Certainly. 2 will. 2 goes into 10 5 times. 2 goes into 8 4 times. All over, and 2 into 2 is 1. You don't have to put the division bar and put all over 1. So this is what that right there reduces to. Now, you got to be able to divide into all 3 or it won't reduce. For instance, if this had been a 7, there's nothing that goes into 2, 10, and 7, so it would not be reducible. But since it's an 8, it can be reduced. And you can break this up into 2 parts and write it -5 plus 4 square root of 2, -5 minus 4 square root of 2, but that doesn't add or subtract together. It won't go any farther. Okay, let's do one more example to close out this section. I'll do again what I did before. I'm going to put the problem up, let you copy it. You won't be able to get the last line, but you'll be able to get everything else. So, let me make sure that you can see everything before I tell you to pause the video. Okay, pause the video now and copy this. Okay, I'm assuming that you copied this. There's one more line after this. I'm fixing to slide it up. I want you to pause the video again and copy this last line. All right, here it is. So put this right up under that. Pause the video now. All right, so let's go back to the problem. Assuming that you've got it all copied. This is a quadratic equation. Now, on this one, we're going to do something a little different. Remember step 1, you have to put it in standard form. That means bring everything across and set it to 0. I could do one of 2 things here. I could add 12x to both sides, subtract 11 across, and that would be in standard form. But typically when we're dealing with quadratic equations, We don't like the number in front of the x squared to be what? To be negative. That's what makes this one different. So here's what I'm going to do. Instead of working with that negative over here with that x squared, here's what I'm going to do. Leave these two terms on the right side and just move this term over to the right. So I'm going to add that 4x squared across. See, it doesn't matter which side the zero's on. So I'm going to add this 4x squared across. Now, it still needs to be first. Now, your A, B, and C. A would be 4, B would be negative 12, C would be 11. Then copy your formula down. Plug your numbers straight into the formula. Replace B with negative 12, put it in parentheses. Replace A with 4, put it in parentheses, and replace C with 11. All right, orders of operations. Negative 12 squared is negative 12 times negative 12, which is a positive 144. Minus 4 times 4 is 16. 16 times 11 is 176. All right, right here, double negatives gives you a positive. All over 2 times 4, which is 8. All right, then subtract the two numbers. 144 minus 176 is negative 32. Now, how do we reduce that? Well, I know there's going to be an I in the answer. And then if you reduce square root of 32, there is a perfect square that goes into 32, and that's 16. 16 is a perfect square, and it divides into 32. So rewrite this as 16 times 2, and the square root of 16 brings out a 4. Square root of 2 stays under, and the I because of the negative under here. So this would be 4 square root of 2i. Now again, I told you, you can use your calculator to do that if you want to. Now, you can't punch the negative in, but what you can do is take your calculator and punch square root of 32 in, and that's 4 square root of 2, but you're going to have an I because of the negative under there. And then the last thing here is if there's a number that goes into all three of these, you can reduce it. And there is. 4, 8, and 12. 4 goes into all three of these, but it's got to go into all three or you can't reduce it. How many times will 4 go into 12? 3. How many times will 4 go into that 4? 1. How many times will that 4 go into that 8? 2. So this problem reduces to 4 into 12 is 3. 4 into 4 is 1. I said 2. 4 into 12 is 3. 4 into 4 is 1. And 4 into 8 is 2. That's understood 1. Now you don't touch what's under there. So that's the answer. If you want to break it into two parts, 3 plus square root of 2i over 2, 3 minus square root of 2i over 2, you can. So this completes solving quadratic equations by using the four methods. Factoring doesn't always work. Square root property doesn't always work. Completing the square always works. And then the quadratic formula. You need to know how to use these four methods, and you need to know the steps in using these four methods, because I will ask you all four of these on the test. This is also the second type of equation that we've solved this semester. The first type was linear equations, and now we've just completed our 7th video on solving quadratic equations. So that completes this section and this video.